Good evening, everyone. My name is Piotr Prus. I'm a Google developer expert for Android. I'm also working at Tilt, which is a startup application for Generation Z for e-commerce and streaming. So we have a lot of moving parts, a lot of animations. We have auctions, giveaways, and all that things. If you have any questions about this app, I'm not the good person to ask because I'm not the user of the app. I'm not from Gen Z, but our users love it. So I will share one of the things that I built for this app, which is Spin to Win, and it will be a spinner for a giveaway. So what this talk will be about? This is the winner spinner, the giveaway carousel. As you can see, it spin, goes to the item, to the winner, to the center, nicely and smooth, slow down, and then reveal the prize. So we'll be talking about Compose, Jetpack Compose in Android. And this is not usual for me because normally I'm talking at some Droid cons or Android conferences. But here, I think I need to ask that, how many of you have some Android development knowledge? All right, that's fine. Half or even more, so that's great. Or how many of you are using Jetpack Compose daily? Okay, not that much. But there will be a part that will not be strictly Jetpack Compose, so we will be talking about animations, and there will be a lot of math that is very universal. So I guess our Swift colleagues will learn something from it also. And then Canvas. And Canvas is also very universal, right? So let's talk briefly about the Compose. So here we need to have some initial parameters to reveal this winner. So first of all, we need to have some list of users, our participants in giveaway, and then we need to have a winner, which is part of participants. And surprise, surprise, when we are displaying this animation, we already know the winner. I know it's a little bit of a lie for the user, but this is how it is. We need to know who is the winner, because otherwise, how could I stop the animation at the good point? And of course, we need to know what is the prize. So having all of that, here is part of the code in Jetpack Compose. As you can see, this is a giveaway winner animation. We have some carousel state for lazy row. And in the content, we have a box that is circle shape with the content alignment center. And then I'm just displaying async image from some random images from the internet. So nothing really there. And then we have the spin, and here the fun begins. So we are calling this launcher effect, so we are calling asynchronous function inside the view. I have this carousel state, and I'm animating scroll by, which means I will be animating by pixels. So I put here quite a big number because I'm taking the item size in pixels and multiply by 1000 my max count. So it's not infinite, of course, but for the carousel, it's good enough because I'm spinning it a few times and then slowing down. So from here, I will show you where we are using that, not only for giveaway, but this technique for infinite spinning is used in our feed. And as you can see here we have top stores and some feature items, products that user can reveal directly from the feed. And this scroll that you see is using exactly the same technique. And the reason I'm showing you that is because in this code, there is a bug. And I wonder if you know what is that bug. And I will give you a hint that this code may cause an app freeze. And when we had this element in the feed where we have a lot of moving parts, a lot of those carousel effects, our app was freezing for a few seconds when we launch it. And it took me hours to find it. Anyone have some guess? I saw some whispers there and there. Maybe you can speak aloud? No? All right. I will show you. So the problem is here. We cannot, like we can of course, but it freezes. We shouldn't scrolling by a big amount of pixels because lazy row works in that way that it calculates and sorry, I forgot the word, creates the view, like measure the view, the place of the view, ahead by one spin or two. So if we take 1000 items, that means that our lazy row, before it renders, needs to know where that place is. So it needs to create all those elements before it starts to spin. So for one, maybe it's not a big deal, but if I had in the feed like 20 of those auto scroll carousels, it freezes the app for a few seconds. So the fix is just to put everything in repeat, so the for each. I'm just repeating that animation 100 times, and then I'm just calling 10 items, and that doesn't make the app freeze, because every 10 items I'm just repeating the thing, and the view do not need to calculate 1000 items ahead, just a 10, and normally 10 are already calculated because this is how lazy row works. So here you can see a few speeds that we were testing before the final giveaway speed. If I remember correctly, we choose 8 items in second. And now we will go to the scary math. I do not see any excitement. Yeah. Thank you. I will try to visualize that, so it won't be that hard to understand. So imagine this is our lazy row. We have those 6 items, and let's say our winner is number 6. So we are scrolling theoretically infinitely the row, and we want from some point we want to slow down the scroll and stop it exactly in the middle, with the winner in the middle of the viewport. So for winner as number 6, that would mean that we need to scroll by 1.5 item. And for the winner number 2, we will need to scroll by 2.3. If the winner is number 4, should we scroll by -1.1? We decided to scroll by 4.2 because we do not want our carousel to go backwards and forward. We just want to slow down moving forward. And if the winner is exactly at the center when we start our second phase, we do not want to stop immediately. We want to add some extra slowdown. So in that case, we'll scroll by extra 6 items. That things rather never happens, but we have that covered. So a few key assumptions. The spin stops with the winner in the center of the viewport. At least one full spin for slowdown, to have nicely slowed down, not immediate stop. We do not want to snap, and we want to apply this ease out curve for nice slowdown effect. And now let's go to code. So we have this lazy list state that is part of the lazy row, and we have some helper functions or parameters that we can use for these calculations. So first we have the index of the first item that is visible. We also have the viewport side size, so we can calculate exactly where is the half of the viewport. Then we have the visible items info. So this collects all the information of currently visible items. And this information is index, key, offset, and size. So all the things that we need to precisely calculate where are those items. And for the indexes, we'll need to know what is the winner index, and as we know already who is the winner. We just need to know their index. But if we are scrolling really fast, those indexes are not 0, 1, 2, 3, but they're actually like 120 or even 1000. So we need to calculate the relative index for all of that, and for that I'm using this floor mode function. So divides this value by the other value, flooring the result to an integer that is closer to negative infinite. And that results to relative indexes. And that will be very helpful in our calculations. So putting it all together, I will go slowly, step by step, how it works. So when we move to the stage, to the second stage, so from the infinite linear scroll to the slowdown, we need to know where which is the index of our winner. So in that case, that will be index 4, so actually user 5. The current index, so we need to know where on the viewport is the current first visible item. So in that case will be 89. We need to calculate the relative index, that will be 5. And then we are taking the item info. So from carousel state layout info, we are taking visible items info dot first. So we have the about first visible item index. About this current index, we know exactly what are the parameters of that item. So the size, the offset. We need to know where to scroll. So I'm just calculating 2 times the list size minus relative index plus winner index. That is giving us 13 items to scroll for the slowdown. And then obviously the center of the viewport. So we know exactly where it is located to stop the animation right there. The child center, because we want the child to stop also in the middle, not at the beginning. And this is something that we are taking from this item info. So we do not need to calculate it before. This is something that the carousel state or lazy row state is giving us. And then we are animating scroll by, taking the item size in pixels, multiply by relative to scroll. So we have the distance to scroll minus the viewport center plus child center. And then we have animation spec, and we are using the is out, and the duration millis is something that we calculate like speed items in seconds, which is 8 divided by 2. So the relative scroll will be taking half of the time than a normal scroll would take for those items. And additionally, we are adding the is out, so it's slowing nicely. So this is how it looks. It's linear scroll, slowing down, and boom. Index 4, which is actually number 5. But here you can see without the numbers and with the addition of the left and right dim. And this is something that I will cover using the canvas. So I think canvas are the most powerful UI element in at least Android, but I think it's for all front-end systems when we can blend things. So in the Android documentation, you can see how many blend modes we have and what we can do with them. And for our purpose, I choose the dist_in, which is keeps the destination pixels that cover source pixel, discarding the remaining source and destination pixels. A lot of destination and pixels, but what it means exactly is that everything that is transparent in our view, it will be dim into the view that is behind. And everything that is black will be fully visible at full opacity. So to add that, we have this lazy row with fill max width. I need to call the graphic layer to inform that in that view, the draw with cache will act as a blend. So it will be using the strategy off screen. Then I'm adding the brush. So it starts from transparent, goes to black, and then from black to transparent, which means that the left side till the black will be dimmed, and then it's full opacity, and then it will dim again on the right side. And then I'm drawing everything, so content first, and then I'm drawing my rectangular, which is with the using of the brush with the gradient. And the result of that is, as you can see, that on the left and on the right side we have nice fade out, dim. Now the winner reveal animation, the thing that after we stop we want to show the price. So one of my favorite quote about computer graphic, it's a computer graphic, so we are cheating all the time. And this is something that said John Hofford on one of his presentations at Google. This guy is doing motion layout and animations at Google for Android system. So the fact how we are revealing the winner is that we know that winner. We know that this will stop exactly at the center of the viewport. So we are just putting another view underneath. And since it's computer graphics and the size will be exactly pixel to pixel the same as the one from the carousel, we are just aligning it to center, and this is all we really need to do. So when the scroll stops and the winner reveals, what really happens is that carousel is like fading out, and the layout that is underneath is fading in, and that's why we are calculating it to the last pixel to have it exactly in the center to have this nice reveal at the end. So I will not go into details how this animation is built. I think it's pretty basic. I'm using here the X offset to show the price from behind that sits there all the time. I'm just using this offset to reveal it. I'm scaling it up and adding some alpha. As I said, there is a fade out and fade in for the carousel and for the price revealing. And at the end, those little stars around there, it's just a Lottie effect. So now we'll have a demo, and I hope nothing will break. So I have here this awesome Mobile Warsaw T-shirt to win.
Wow, the application was made to
Exactly. That was sole purpose for that. I calculated before that we have like 7 rows, but let me check it again. Like 1, 2, 3, 4, 5, 6, 7. So I know the winner in the moment I'm starting the app, but I can show you in the code that I'm using the random function. So I really do not know the winner.
What did you say about the cheating or something?
So, but you'll see now, we have here the 7 rows, the animation starts. You can see I did it exactly for this event. Just added the background, nice, right? So, you see?
Wow.
So, for the next round, we have the row 2. So that's like 3 of you guys.
The red one on.
Should we count you, Piotr, or not?
Yeah, we can skip, but maybe I don't know. We should insert somebody instead of me.
Yeah,
Let's cheat. No, 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 no. No, we already have the row 2. So just between you two guys? I think so. That will be.
So they can exchange it in the company.
So Piotr told me that he has a different size of the t-shirt, so you'll talk with him about that. I changed to 2, and as you can see, we have the code updated, and the winner is, so from my left.
You have a t-shirt on the delegation.
That's for you.
Right size.
Are we going for another prize? All right. So let me change a few things in the code. We have 7 participants now. Row and here will be JetBrains. So we have the JetBrains code subscription, right?
After the rolling, somebody who will win, we don't know who.
Guys, I can really show you this random thing.
The most important is to repeat it always.
You see here? Barely. Okay. Let me try to. You see? It's just participant.random. I really don't know. Okay. Let's open this random. Let's open this random. This is Kotlin random since version 1.3, okay?
1.3, yes, that's it.
That's it, yeah. This is the broken one. Yes.
I remember that.
Okay, let's go. Let's see. The next round is for row number 2. What can I say? Let's say it's the index number of 2. Row number 3. So 1, 2, 3, 4, 5, 6 people. Counting from my left, you're number 1, and you're number 6.
If we'll be 1, then we know it is random.
So 6 people and the person. Thank you. It's running, and the winner is. No, please don't be 1. 2. Yeah. Piotr will give you the code. I couldn't show the code here. For some reasons, they just didn't let me, but yeah, should be there. So going back to presentation, that's it. Thank you for listening. If you have a question, please raise a hand, or also you can ask me some questions at the networking session. I will be here. I do not see questions. I think this is because of the math, right?
Random.
Or the random function. This is when I lose you with random.
I was just wondering how the background for the winner is displayed. It's like always under the scroll area, and when the winner is selected, it just pops up.
So the question is about the background of what?
Of winner with stars, with prize, and
There were some stars animation.
Oh, the lottery animation. You ask about that?
yes. So I'm wondering how it is hidden right now.
Yes.
Yeah. And when winner is selected, so it just pops up.
Okay. So the question is where is the background and all the things related to winner during the scroll? So it is just under the scroll with alpha 0. And then when we are going to stage 2, I can show you that here. Let me try. Okay, so here I have this go to stage 2 that is normally handled by backend. We are observing an event from the backend that we are ready with the winner. We can go to the so sorry, we have the winner. We are ready with the spin, and we want to go to the second phase. We are doing that to synchronize with iOS to show this reveal at the same moment. But for the purpose of this demo, I just made it delay for 5 seconds, and then I'm changing this go to stage 2 to true. And when that is happening, so let me go here. Okay. So here I have another launched effect. So when we are moving to second stage, I'm calculating this slowdown and everything. And here you can see that the winner is selected. And I'm starting this launches, which is winner scale animatable. I'm just animating it to 2. And then position winner text and font size winner text is changed to 1 and 15. So it pops in.
You mentioned at the beginning this freeze related to the calculations. Was it something that was like in your face immediately, or you not?
Yes.
Okay.
Yeah, you're launching the app, and for some reason it was black screen for 5 seconds. We had that on production, on demo, on dev apps, and we were searching for it for some days.
1.3 it was.
Yeah, this is because of the Kotlin 1.3 exactly. Yeah, let's blame Kotlin then. Oh. Okay, I guess networking now.